You already have seen this one. Okay, it's just a revision lah. It's just like a revision for first part of probability to permutation and combination. Some of the question I think you can answer lah without my guidance or my lecture. Okay, but still we need that one to proceed to the next step, which is in the probability, let's say conditional probability and so on. Okay, first one is multiplication principles. Okay, so if an operation can be performed in A ways, okay, kaedah A cara lah ya. And if for each of these, a second operation can be performed in B ways, so that's mean if two operation, it can be performed together in A times B. So katakan nak pergi daripada sini, katakan nak pergi daripada UTM. Okay, UTM nak pergi ke Taman Universiti, mungkin ada 3 cara, so 3. And then you have UTM nak pergi ke mungkin Taman Tun Aminah ke, mungkin ada 5 cara. So all together you have 3 times 5. That's mean 15 ways. Okay, so that is your multiplication principle. Okay, itu basic lah ya, basic counting. Okay, what we want to deal in here is on your permutation and also combination. Okay, yang kita nak fokus dalam this one is on the permutation punya concept and also combination. Okay, you need to know what is the definition for permutation. So permutation is an arrangement, okay, arrangement, susunan of all or part of set of objects where the order of the selection is important. Okay, that's mean dia punya tu arrangement of all or part of sets of object, kamu punya susunan tu, di mana tertib of your selection tu, tertib cara kamu menyusun tu is important. Okay, where the order of the selection is important. So how do you want to arrange 3 letters A, B, C? Okay, let's say you have 3 letters A, B, C. Can you write apa alternatif dia kalau kita nak susun 3 letters A, B, C? Maybe you can write in your chat message. Listkan all possible outcome dulu. Instead of you just give me the answer. Okay, for example, let's say, okay, first you want to arrange A, B, C. Next. A, B, C. Okay, next step, how you want to arrange this one? Okay. So, ada berapa tu? Okay, B1, 2, 3, 4, 5, 6. Okay, good. Okay, and then you have this one lah, ya. So, you will have ABC, BCA, CAB, CBA, BAC, ACB. Okay, cara susunan yang berbeza. Gabungan dia mungkin sama, which is your combination is the same thing. Okay, let's say combination ABC, CBA sama. Okay, but the arrangement is different. Okay, so now the order of the selection is important. So that's mean you have 1, 2, 3, 4, 5, 6 possible ways. So the possible permutation is just n factorial. So again, or you can have 3p3 lah. Okay. So again, you have 3 letters. So you have 3 factorial. So 3 times 2 times 1, which is 6 possible ways. Okay. So that is how you want to arrange 3 letters A, B, C. Okay. So permutation relates to the act of arranging all the objects of a set into some sequence or order. So permutation is basically an arrangement of objects in a definite order. So permutation of n different objects, you can write npn or n factorial. Okay. So in your calculator, you can press npr tu ya. npr in your calculator. So that's mean katakan npr. So inilah dia punya tu, n minus n factorial over n minus r factorial. Okay. So example 2.4 in your module. Okay, you have how many ways can the letters of the word world can be rearranged. So you have 5 different objects, 1, 2, 3, 4, 5. So 5 different objects because we don't have the same word appear 2 times or 3 times. So 5 different objects. So permutation of n different objects. So it just have 5 factorial. Okay, so that's mean in this case is 120. Okay. Okay, task 2.4. So identify the number of ways the letter generally can be arranged. So again, we have different words or different objects. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, you will have 10 P10, or you can write down 10 factorial. Okay, so 10 factorial, kira lah. You have 3,628,800 ways. Okay. So that is your permutation for n different objects. Okay. So again, you will have permutation of R object from n objects, and the other one, n different object comprising R identical objects. Okay. So first, kita tengok dulu R objects from n objects. So the number of permutations or ordered arrangement of R objects, okay, taken from n different unlike or non-repeating object, you can write as n PR. Okay. So from n, we will choose R object. So it will give you n factorial over n minus R factorial. Okay, kalau R tu different object lah ya. Okay, kalau n different object, but you have R1 identical objects. Maksudnya R1 sama, R2 sama, RK sama. Okay. So permutation of n different object of which R1 identical objects are of one kind, R2 identical objects are second kind, and RK identical objects are kth kind. So bentuknya dia akan jadi macam ni ya. So you will have n factorial over R1 factorial times R2 factorial sampailah kamu ada apa objek yang sama. Okay. Total number of your words or total number of your objects dividedkan dengan bilangan objek yang sama. Okay, ini case kita kalau n different object but you have R identical objects. Okay, kalau this one NPR ni adalah n object for R different object lah ya. So that means this one is n factorial over n minus R factorial. But if you have R identical object, so that means n factorial over R1 factorial, R2 factorial, RK factorial. Okay. Okay, for example, let's say kita ada perkataan lah. Let's say if your word appears 2 times, so that means it belongs to n different object, but consists of R identical objects. Okay. So if we have example 2.6 in your module, if 4 alphabets are to be chosen from A, B, C, D, E, and F, such that repetition is not allowed, then in how many ways it can be done? Okay, you have 4 alphabets to be chosen from A, B, C, D, and E. And then again, repetition is not allowed, and how many ways it can be done. So let's say, dia punya procedure lah, okay. I think you already know the answer if you refer to this, the solution in the module. Okay, we have 1, 2, 3, 4, 5, 6. So that means your n is equals to 6. Okay, your R is 4 alphabet. So of course, this one is 6P4. Okay. You can also have, let's say, you have 4 alphabets, okay, 4 space, say here, okay. So you have 6 possible values to fit in the first one, the first space, okay. So that means you have 6. Second space, because this one repetition is not allowed, so you're only left with 5 choice. The third one, 4 choice, and the last one, you have only 3 choice. So you have 6 times 4 times 6 times 5 times 4 times 3. So you have the answer. So the same thing, 6P4. So you have 6 factorial. Okay, 6 minus 4, 2 factorial. So 6 times 4. 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. So you cancel out here. So you have the same answer. Okay. So this one, for this kind of question, normally you can give directly your answer. Okay, tak perlu tunjuklah kamu ada 4 space, lepas tu ada apa? 6 possible ways to fill in the first place and then second and so on. Tak payahlah ya. So just give directly 6P4 ataupun you can have 6 times 4 times, 6 times 5 times 4 times 3. So you get the answer. Okay. Sebab dia punya tu repetition is not allowed. Okay, let's say if repetition is allowed. how many ways it can be done if repetition is allowed? Apa jawapan dia? Anyone? Okay. Lain-lain jawapan ke? Only one solution? Which one do you think? Okay, that's mean kalau let's say if the repetition is allowed, so that's mean you have the first one is 6, second one is also 6, the third one is also 6, and the fourth one is also 6. So 6 to the power 4 lah actually. Okay. Okay. So that is the example. Okay, just go back again. Okay, so try this one. Suppose you have been hired by Astro and part of your job is to determine the shows to be shown on Monday night. So there are 27 shows available and you must select 4 of them. Okay, how many different sequence of 4 shows are possible? So what is your answer? And then when you read the question, you need to identify whether that question is designed for permutation or for combination. Okay, we haven't go to combination yet. So that's mean the keywords here is how many different sequence. Maksudnya tertib dia. Okay, of 4 shows are possible. So that's mean altogether you have 27 shows P4. So you will get that answer. Okay. So that is for exercise and additional question. Okay, now you refer to example 2.7 in your module if you already have that, the module. So this question asks you how many even counting numbers can be formed from the digits 4, 5, and 6 if no repetition is allowed. Okay, even counting numbers can be formed from the digits 4, 5, and 6 if no repetition is allowed. Okay, maksudnya dia nak dapatkan even number lah, even counting numbers, bilangan nombor genap. Okay, you have digits 4, 5, and 6. And again, syarat dia, there is no repetition is allowed. There is no repetition. Okay. So again, you have even counting numbers. So you have even number, you only have 4 and 6. Okay, for a single digit counting number, you only have 2 choice, which is 4 and 6 can be considered. So number of single digit, even counting numbers is just 2. Maksudnya kat sini katakan kita ada first space ni. Ada 2 cara je yang kita nak masukkan. Either 4 or 6. So that means you only have 2 choice. Okay. So next, if you have 2 digit, maksudnya kat sini lah 2 digit. Buatlah 2 macam tu. Okay, 2 digit. So 2 digit counting numbers, we can only consider either, okay, this one lah, either 46, kalau nak senaraikan, either 46, 64, 54 or 56 because you want even number So either 46, 64, 54 or 56. So that's mean you only have 4 choice. Okay. Ataupun let's say katakan so katakan kita buat macam ni, space ni. So katakan yang first digit ni kita identify dia. Okay, ini 4. Ini adalah 6. Maksudnya kita ada 2 digit je. 4 and 6 for even number. Okay. So that's mean 4 ni kalau saya fixkan only one choice je saya boleh masukkan. Yang depan lagi first place tu, it can be either 6 and 5. So you have 2 choice. Okay. So second line, second order, katakan yang 6 ni saya dah fixkan. So only satu cara je nak letak nombor 6 tu. So only 1. Yang kat depan dia, again, without repetition, so it can be either 4 and 5. So 2 possible ways. So that's mean you have 2 times 2 lah. So that's mean 2 plus 2 lah. So in this case, you have 4. 4 possible ways lah. Okay. Okay, that one. So again, for 3-digit counting number. So 3-digit counting number, tapi yang at the last tu kamu nak even number. Okay, so either 456, 546, 564 or 654. Kamu boleh listkan kalau kamu nak listkan. Ataupun kamu boleh buat cara, tentukanlah dia punya digit dia macam mana. Okay. So you have number of 3-digit even counting numbers is you have four possible ways. So alternatively, we can have either, so the same thing here. Okay. So katakan kat sini, again lah. Kalau nak buat satu-satu pun boleh sebab kita ada 2 je even number. So again sama ada kita nak masukkan nombor 4 ataupun nombor 6. Okay. So again, this one, you have 4 or 6. So, you have 4, kalau fixkan 4 kat sini, maksudnya only one ways lah. Ini pun only one ways. So yang kat depan ni, ada 2 cara, 2 lagi value yang tinggal. Okay. So again, without repeating the same number, so only one possible ways je. Sebab kita ada 3 digit je. So ini pun sama. Ini 2, ini 1. Okay. So all together you have 2 times 2 which is your 4. So that's mean you have 4 plus 4 plus 2. So you have total number of even counting numbers. You should have 10. Okay, 10. That's mean 10 possible values. Itu maksud soalan ni. Okay, we go for a single digit apa. And then 2 digit apa. And then 3 digit. Because we only give you a 3 digit. 4, 5 and 6. But the question asks you even counting numbers. So maksudnya N kamu tu mesti nombor yang genap lah. Okay, so that one. Okay. So nanti kita buat dia punya task tu. So again, example 2.8. So 2.8, you want to find the number of odd. Okay, odd 3-digit counting numbers that are less than 700. Okay, this one, this one dia tak cakap apa kan? Okay, so again for this one, if the question doesn't mention anything, we just assume the repetition is allowed. Okay, dalam modul tu kita tak tambah ya if repetition is allowed, but the solution that given is according to repetition is allowed. Okay, yang tadi saya highlight example 2.7, no repetition. Okay, but this one. This solution is designed for repetition is allowed. Okay. Okay, suppose you have the possible number of 3-digit odd numbers that are less than 700. Katakan kita ada X, kita ada Y, kita ada Z. Okay. So again, digit number. Okay, kalau nombor digit, that means you have 0, 1, 2, 3, 4, 5, 6, 7, 7, 8 and also 9. Okay. Okay, so again you want odd numbers. So odd numbers, so you can have either 1, 3, 5, 7 and 9. Okay, so for 3-digit number, for odd number, okay, you have 5 possibilities. Okay, 5 possibilities. Okay, so that's mean yang the last value to Z ni, space dia macam ni lah 1, 2, 3. Okay, so you want odd 3-digit number. So of course yang the last value tu mesti nombor ganjil. So nombor ganjil odd number, you have 5 possible ways. So 5 possibilities. Okay, so whereas for the second digit, okay, that's mean this one you have 5 possible ways. Okay. Whereas for the second digit, we may have all possible digit from 0 to 9. Because this one, repetition is allowed. Maksudnya kita boleh repeat balik nombor yang sama. Even though dia adalah nombor ganjil, tapi kita boleh masukkan balik. So that's mean all together you have 10. So why 10? Because you have 0, 1, 2, 3, 4, 5, 6, 7, 8 up to 9. So you have 10 possibilities. Okay. So the first one must be less than 700. So less than 7. Ini 7. So less than 7. So it can be either 1, 6, 5, 4, 3, 2, 1. Okay. Kenapa tak 0? Sebab first digit takkan nak letak 0. Kalau 0 kat depan, maksudnya dia akan jadi 2 digit. Okay, because you want 3 digit. So that's mean you only have 6, 5, 4, 3, 2, 1. So that's why in the first place you have only 6 choice. So 6 times 10 times 5, which is you have 300. Okay. So it can be anything lah. Kalau find the number of odd 3-digit counting numbers less than 500, katakanlah pula. So benda tu pun akan bertukar. Okay, bergantung pada ni. So kalau digit, that means you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So check the question. In this case, you want number of odd 3 digit. Maybe our question, number of even 3 digit. Kena check lah. What is your even number? Okay, why the first is only 6? Because we didn't include 0. Okay. Ini 0 ni, kita tak boleh letak kat depan. Katakan, no, takkanlah 0, 4, 5 macam tu kan. Kalau 0, 4, 5, 0 tu tidak memberi apa-apa maksud. So, dia akan ada 45 je kita panggil kan. So, dia jadi 2 digit. Okay, sekarang kita nak 3 digit. So, we only consider 6, 5, 4, 3, 2, 1. Okay, Haris? Okay. Okay, we try the exercise. Okay, cuba kita buat ini. Task 2.6. Jawapan dah diberi kat dalam tu. Macam mana kita nak dapat 32 jawapan dia? Okay. How many odd counting numbers can be formed from 4, 5, 6 and 7? If again, no repetition is allowed. Okay. Okay, nombor yang diberi tu hanya 4, 5, 6, 7. So kita nak odd. Okay, so kalau odd number, so that's mean you can have either 5 and 7. Okay, cuba fikir dulu macam mana kita nak selesaikan this one. Okay, so again, kita based on your example tadi, example 2.7 Okay, so we will have a list of single digit and then 2 digit and then 3 digit and then 4 digit. Lepas tu kita total up. Okay, first step So first step, single digit dulu. Kita only consider single digit. Okay, sebab dia sebenarnya soalan dia lain sikit pada yang ni. Kalau yang ni dia dah bagi odd 3 digit. It already informed to you. Okay, yang okay, ini macam ni lah Okay, how many odd? Okay. So that's mean first you consider only single digit. So kalau single digit, so single digit you only have choice either 5 or 7. So that's mean kalau ini katakan saya buat macam ni lah space. So ada nombor 5 ataupun nombor 7. Okay. So that's mean you will have 2 possible ways. Either 5 ataupun either 7. So 2 possible ways. Kita ada 2 nombor, sama ada nombor 5 ataupun nombor 7 je. So 2 possible ways. So that is your single digit. So now you consider 2 digit. So 2 digits, that's mean, katakan, inilah. Okay. So again, for 2 digits, you also have, the last value, it should have either 5 or 7. Ada 2 possible ways. Maksudnya sama ada ini bawah ni, 5 ataupun 7. So 2 possible ways. Okay. So yang kat depan tu, katakan kita dah masuk ni, without repetition. So without repetition kat depan ni ada berapa possible ways lagi? Okay, yang kat belakang tu kita sama ada 5 ataupun 7. Kita akan pilih salah satu. Okay. So that's mean kita ada 4 digit. So betul 3. Okay, good. 3 So that's mean 3. Okay, sebab salah satu je kita akan masukkan. Kalau macam confuse mungkin buat macam ni lah. Ini 5, ini 7. Pun boleh lah. Sama je. Okay. So this one, kalau ini 5 ataupun 7, maksudnya kalau 5 kita dah fix kan, kita ada 1 je lah possible ways. Ini kalau 7, 1 je lah. So that's mean kita ada lagi 3 value kat depan. Ini pun sama. So ini 6. Ataupun that's mean you have 5 or 7, so 2 possible ways. Okay. The next one, it should be in the first place tu, ada lagi 3 possible ways because this one is without repetition. So altogether untuk yang second digit, you will have 6 possible ways. Okay. Ya, sebab ini baca soalan dia, no repetition. Okay. The next one, 3 digit. Okay, 3 digits. So you have 3 space. 3 digits. Again, the last one, it should be either 5 or 7. Ya, kalau kita buat sekali ni, 5 or 7. So you have 2 possible ways. Okay, yang depan dia mungkin ada lagi 3 cara. Okay, yang depan lagi mungkin 2 cara je lah. So again, this one you will have 12 ya. Okay, so ini either 5 or 7. Okay, salah satu je. So dia tak boleh repeat. So sebab kita ada 4 nombor. So yang depan ni 3. So tak boleh repeat, kurang lagi 1. So tinggal yang depan sekali. 2 possible ways saja. So 2 times 3 times 2. So you have 12. Okay, kalau nak buat satu-satu pun sama juga ya. Katakan nak buat satu-satu. Okay, ni. Okay, so katakan ini kamu nak letak 5, ini kamu nak letak 7. So only one way lah how you can put 5. Only one way how you can put 7. So if only we already fix 5 here, so that's mean we have 3 choice lagi kat depan. So dah ni without repetition, 2 lagi kat depan. Okay, so the same thing, 3 and 2. So 2 times 3, 6. So 6 plus 6 yang kat bawah tu adalah you have 12 possible combination. Okay, that is the last one. Okay, the last one, 4 digit. Okay, 4 digits. So again, 1, 2, 3, 4. Okay, so the same thing, 5, 7. So okay, you have either 5 or 7. So you have 2. So this one 3. And then the first one 2. And then 1. Yeah? So 2 times 3, 6. 6 times 2, you have 12. Okay, so you have 2. 6, 12, so, and then plus 12. Okay, so that's mean 8 plus 20 plus 12, which is 32 possible ways. Okay, so itu maksudnya how many odd counting numbers. Okay, dia bagi 4 digit je, 4, 5, 6, 7. Tak perlulah masukkan pula digit yang 0 up to 9 tadi. Okay, sebab dia kata form from 4, 5, 6 and 7 saja. Okay. Now you want to have odd number. So odd number either 5 or 7. So kita consider kalau single digit, you have 2 possible ways. If you have 2 digits, so that's mean again, you have 6 possible ways. So kita letak ini 2. So yang kat depan tu mungkin ada lagi 3 cara lah kita masukkan. So you have 3 digits, again 3 space. So we have 2 possible ways. Again without repetition, so 3. And then the first one should be 2. And then the last one 4 digits. So already fixed 2 here. Okay, so 3 possible ways lagi. Dah ni without repetition again, yang space yang kedua 2. So yang first tu only 1 possible ways lah. Okay, so altogether you have 32 possible combination. Okay, ada apa-apa soalan tak this one? Task 2.6. Ya, follow lagi. Okay, saya cuba kamu buat this one. Maybe I give you around berapa minit nak buat ni? 3 or 4 minutes. Cuba selesaikan dulu. Okay, baca dulu dia punya soalan. Mungkin kamu boleh guna balik apa yang knowledge kamu dah belajar waktu SPM. Okay, sebab dia, kali ini dia tak adalah jalan kerja yang very systematic untuk menunjukkan dia punya kaedah dia. Okay. So you want to find the number of event, even 4 digit number, counting numbers that are less than 8,500. Okay, cuba buat dulu. Nanti kita discuss. Okay, so this one you want to find the number of even 4-digit counting numbers that are less than 8,500. Okay, digits, so that means 0 up to 9. Okay, so now you want to find, okay, Kiwi dapat 3751. The answer should be 3750, Kiwi, in the module. Kiwi ke Kiwi? Okay, 3750. Check your answer. Is there anything wrong? Okay. So again, you have even number is 0. Okay, good. 3750. Okay. So again, you have even number. So even. So that's mean you have 0, 2, 4, 6, 8. Okay, so that is your even number. Anyone get the same answer as KW? Kaiwei? Dapat tak? 3750. Okay, I'm not sure how you proceed with your procedure. Okay, first, let's say, okay, you consider the value, okay, you consider the number of possible ways to get less than, sebab kita splitkan into two, less than 8,000. Okay, in the first category, we consider. Second category, we consider between 8,000 to 8,500. Okay. So the question is slightly differ from the first one ini. Ini less than 700 senang. Mudah sikit lah Sebab dia tak ada less than 700, maksudnya yang paling, the lowest value is 699, right? Okay. But this one, you have 8,500. 8,500. Okay. So if you have the value 8,499, so that means it's still less than 8,500. Okay. So alternative way, you split into two. First, you consider the number of possible way which is less than 8,000. Second, you consider between 8,000 up to 8,500. Okay. So you want to build up 4 digit. Okay. Even 4 digit. So 1, 2, 3, 4. Okay. 4 digit number. So that's mean you have 1, 2, 3, 4, 5. 5 possible ways to have even number. Okay. With either 0, 2, 4, 6, 8. That's mean the last value should be either 0, 2, 4, 6, 8. So 5 possible ways. Okay. So this one again, with repetition, kita consider with repetition. The answer with repetition. So this one with repetition. Okay, maybe in the question, if the question stated no repetition, so that means the question is designed for no repetition. But if the question doesn't stated anything, so you solve using with repetition. Okay, tapi mungkin dalam test tu kita akan highlight lagi lah kalau either with repetition or without repetition. Okay. So again, so the last value is 5 possible values. Okay, because you have 0, 2, 4, 6, 8. Okay. So again, with repetition, so you have digit, you have 10 digits. So this is 10 possibilities, either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, again, with repetition. So again, 10 possible ways. Okay, the first one. The first one you get over less than 8,000. 7. Okay, good, Aris. Okay, so 7 times 10 times 10 times 5. So you will have, kira kat sini berapa? Okay, so again you have 3,500 Okay. So that is the first one. So now you consider between 8,000 and 8,500. Okay. So again, the last value, you have even number, which is 5 possible values. Okay. Yang kedua, that is 10 digits. So the same thing, 10 digits. Okay. So now we, sama So now sebab kita ada 8,000 dengan 8,500 ni. So yang ketiga tu should be apa? Third space dia. Okay, good. 5. Okay, because you already have apa? You have 500, so that means either 4. Sekejap, saya bulatkan. So either this one, Okay, less than 5. So either 4, 3, 2, 1, 0. So you have 5 possibilities. Okay, the first one. So kita ada 8, kita ada 8. So only 1 je lah. Okay, so 1 times 5 times 10 times 5. So again, here you have 250. So 3500 plus 250, so you get 3750. Okay, so that is your total possibilities. Okay. So maksudnya bila soalan bentuk macam ni lah ya. So even 4 digit counting number, so mungkinlah dalam soalan test ke apa ke, kita boleh tukar lah odd pula. Okay, macam mana dia punya case dia macam mana. So ini kita ada 8,500. Kalau kita ada 8,000 je, less than 8,000, so your answer should be like this lah, 3,500. But since you have 5, so first you find less than 8,000. Second part, you find between 8,000 and 8,500. So again, you have 5 possible ways to put your even numbers. And then again, with repetition, so 10 possibilities. So because the third value is 5, so we only have less than 5, which is 4, 3, 2, 1, 0. Okay. And then the first one, you should put 8 lah. So only one way how you can put 8 here. So 1 times 5 times 10 times. Okay, so 250. Okay, so that's for task 2.7. Okay. Ada apa-apa soalan ke? This one? Okay. Okay, task 2.8 dengan task 2.9, I think you can do on your own. So, kalau task 2.8 tu, it just calculate the number of ways 8 people can be seated on a bench if only 5 seats are available. So, that's mean 8, P5, Okay. So, for task 2.9, you have 20 students, which the top 3 will get prize. So, how many possible ways? Again, you have 20, P3. Okay, this one I exercise 7 Okay. Okay, now you refer to example 2.9. Example 2.9 in your module. So you have how many ways can the letters of the word statistics can be rearranged? Okay, kita ada perkataan statistics. Okay, all together you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 factorial. Okay, divide. This one is n objects, but with are identical objects. Okay, are identical objects because you have S 3 times. So divide by 3 factorial for S. T again, 1, 2, 3, 3 factorial. Okay, I, you have 2. So 10 factorial divided by 3 factorial times 3 factorial times 2 factorial. So you get this one is 50,400. Okay. So that's mean that is the word with the same objects. Okay, the last one, task. The last one. Task 2.10. Okay, Arif want to change his password, which is AARIFF8, but with the same letters and numbers. So in how many ways he can do that? So dia ada apa tu? 1, 2, 3, 4, 5, 6, 7 Okay. A comes out with 2 times, F also 2 times. So you have 7 factorial. Okay, divide by 2 factorial. FF pun 2 factorial. Okay, 7 factorial over 2 factorial, 2 factorial pun dapat apa? What did you get for this value? 1260 So this one 1260. Okay. Okay, minus, because he want to change his password, which is this one. So that means he will came out with different password. So that's why minus this password. So minus 1. So your answer should be 1259.